So our goal for chapter 2 really is to learn how to find the ratios and proportions. Again, ratios are just saying there is this to that, okay? I can say fractions as a ratio. Ratios just represent this much to this much, a relationship. It talks about expressing ratios in the lowest terms. You don't necessarily have to worry about that, but that's similar to like fractions. We're trying to just say these in lowest terms, use the best numbers we can, and we want to solve them using that missing quantity, the unknown variable, which is where you just use x. Again, you could use any letter you wanted to, but I just say x is the simplest. You could use z, I guess, if that helped, but we're using something right to represent an unknown quantity, an unknown amount, and you want to make sure you set it up correctly. That's what we're going to talk through today. And then using the correct unit of measurements for the unknown variable, solving x, learning how to prove your answer. They call that proof, and that really just means like kind of checking your answer, showing that it does work, that it is the correct answer. And that's the positive ratio portion. The two positives. There's another method of medication calculation that I love called desired over have. Don't stress that one today. We'll get to that one, and I'll show it to you, but the book doesn't teach it, and not a lot of books teach desired over have. That's my baby. I love that method because it's short and sweet. Ratio proportion is long-winded, but the positive ratio proportion is I can use it to solve about anything, and once I learn it to set it up correctly, it's the same forever and always, okay? It just stays the same. And so learning this formula and doing stuff this way in this class, you will never have to change how you set stuff up from now to the end of the class all the way through all of nursing. That's the good news about it. It doesn't change. The only thing that changes is the problem you're dealing with, and the only thing you have to learn how to do is pull out the right information, and that's what we're going to work on. So again, just recapping, a ratio is basically just a comparison of two numbers, a comparison of two quantities, two amounts of something. And there, again, the book tells us there's two ways to express it. You can use ratio proportion and write them as fractions, but everyone gets scared when they see a fraction and they get confused, and so I just like the little colon guys. The little colons help me keep it a little more cleaner. So again, it's saying 2/3 or 3/4. You technically could say 2:3. 2 is to 3, 3 is to 4, that sort of stuff. And you can simplify ratios into those lowest terms like fractions. If you kind of remember fractions, some from grade school and stuff, fractions can always be simplified. If I said 50 out of 100, well, I can simplify that down more, right? Basically, that would actually simplify all the way to 1/2, wouldn't it? 50 out of 100 is a half of a dollar, 50 cents out of a dollar. So you can do that. Most of the time for the problems we're going to do, and you're not going to have to stress doing that. But the proportion part, again, the ratio is each individual side, saying this is to that. The proportion is the equal sign, putting those two ratios together so that I try to equal them out, okay? And we use this, right, for calculating medications. The book makes a good point with their PowerPoint here that we alter the quantity on hand, but we maintain the same ratio. It's saying that all we're really altering is whatever we need to fit what we're trying to order. What we're trying to do is keep the same ratio. We're not trying to change stuff up. And so all they're saying up here, example, is you can kind of see this. Like it's saying 1 is to 4 as 3 is to 12. What is that saying? It's basically saying, well, if I take, right, 3 times 4, it gives me 12, is what it's saying. It's saying that this is equivalent. And so let's look at the medication stuff. That's where it gets into the brass tacks. So again, you can see that there steps for this again is like once we set it up correctly, it's multiplying that means and extremes. Multiplying the middle, multiplying the outsides, and then I can do division if I need to. So they gave us a math one that has no units, it's just pure math. So basically they're saying 2 is to 3. It's saying that 2 things to 3 of them equals 6 to however many things. That's what the x is representing. So you can see if I do the math, if I do, okay, the means and the extremes, that's the middle multiply and the outside. So 2 times x is on the outside. When I do 2 times an unknown number and a letter that I'm trying to represent, it just leaves me that, 2x. That is saying, that is still, when I write that, I'm just writing, hey, in the future, I needed to take 2 times the x, but I can't do that until I know what it is, so I have to find out what x is. The middles is the 3 times 6, which is 18. So then I get stuck with something that looks like this. And I mentioned this before last week. This goes back to a little bit of algebra, but it's just saying, hey, I have an x, I want to solve for it. Meaning I want to get it by itself so I can figure out what x equals. And the way to do that is try to get rid of numbers that are attached here. Right now this 2 is multiplied by x, and so I can't do anything with that 2. But what I can do, the only option I have is to do whatever the opposite of multiplication is, which is division. So 2 divided by 2 is itself, is 1. It cancels it out because 1x is the same thing as saying x, because 1 times anything is that thing, right? So 1x just leaves me x by itself, but whatever I do on one side of the equation, I have to do on the other. So now I'm taking 18 divided by 2, which means I finally have x equals 9. One of those numbers, 9. And so what it's saying here is that I have an answer. If I want to figure it out, make sure that answer is correct, should be, oh no. We'll talk about proof, but I can always, it's going to be very redundant today, I can always take this x I found, this 9 now, and plug it back in up here. So I'll write it a little bit bigger. If I plug that back in for the x, now you can kind of see what this is, right? Like 2 is to 3 as 6 is to 9. It's like saying that these two fractions are kind of equivalent. You can see that 6/9, if I was to reduce that as a fraction, would be 2/3. So they are equivalent to each other. That's all it's saying. So steps, setting up. Setting up is the next couple slides. We want to make sure we set some of these up correctly. And again, we're going to have lots of practice today, lots of practice. And this is what the book recommends of how to set up, and I just recommend you stick with this formula. Because it's a proportion, and each side of it, of the equal sign, is equal to each other, I can kind of throw what I want on either side, and I'm not really changing the problem. Again, why we do stuff a certain way, I always recommend you do something consistently, right? Because if you get in a habit of I'll just put it willy-nilly and don't always put what you already have or know on the left and what you're trying to find out on the right, you just set yourself up for more mistakes in the future. So our goal in math is always to find something to fall back on and limit mistakes. So let's just keep it simple. And this is also something you can do if you have this down. It limits mistakes in the field. It limits mistakes on the fly, that sort of stuff. So again, each side of the equation is set up the same way every time, and once you learn this and have this down, I promise you, you will never need to change this. You do not need to alter it any way. There's no other steps. There's no other putting unknown variables. There's no other thing that you have to do besides get this down first and pull the right information in the right place. That's it, okay? So on the left-hand side is what you know. On the right-hand side of your equations, what you want to know, what you're wanting to find out. So here's your step by step. And this is what I'll repeat all day as we do this. So first, read the problem, identify what the unknown is. That means we need to read it and figure out what we're trying to find. When we look at these word problems in a second, it's going to be all about, okay, finding out what we don't know. And you'll see this example coming up. I'm just going to walk through this and then we'll do this together in practice. And then, so that's the first thing. So I find out, basically I always say this as basically like, what's the question asking you for? If the question's asking for, how many tablets do you give? How many people is there, blah, blah, blah. How many this, how many that? That's a good indicator of, hey, here comes my X, my unknown. So I figure that out first. I have my X. I need to look at a problem and say, the ratio on the left-hand side is supposed to be what I have or what I know. And again, examples of that is wording like on hand, in formulary, in the pharmacy. What medication do you already have when we're talking about medications? What do you already know? What's given to you? What ratio is given to you? So that could be anything from like, again, if I grab a Tylenol bottle, right? And I look at that Tylenol bottle and the label says there are whatever, 60 tablets in here. Each tablet is 325 milligrams. So what do I know there if I read that bottle and say that? Right, so one tablet is equal to 325 milligrams, right? There's what I know. That's probably them doing stuff outside, yeah. They're doing something with the sewer or something out front. There's going to be a lot of construction happening out front for a while, so we'll just have to, as long as you don't hear, booms or anything like that, we're all right, I think. Well, you might hear some booms, but. Yeah, so what I just painted you looking at a Tylenol bottle is Tylenol is saying that, hey, if you grab one of these tablets, they are worth exactly 325 milligrams. Bam, there's what's on hand, there's the pharmacy, there's what I know. There's the 325 milligrams is to, there's your colon, one tablet. So let me just write that as we go, right? I'm just giving you a scenario. So that's saying that, come on. It'll catch up eventually. Or it won't. There it goes. That was really slow. So again, this is side of the equation is what I know. And this is the, no, on hand, that sort of stuff. This is a ratio, like you said. This colon represents is to this. So 325 milligrams is to every one tablet. Every one tablet is worth 325 milligrams of medication. In this case, we're talking about Tylenol or something. So just to give an example. If the question was, what's the X is always going to be what I'm trying to find out, what I want to know. So if I'm using this Tylenol example, we'll just keep that example. Let's say you wanted to take the normal amount of Tylenol, 650 milligrams. That would be on the right side. That would be what I want, desired, ordered, prescribed, words like this, right? So the doctor says, hey, for pain, take 650 milligrams of Tylenol every 4 hours. Every 4 hours and all that stuff doesn't matter because I just need to know how many pills do I take when I'm supposed to take them. So that would go on the right-hand side. That is the, again, the want to know or desire to know, however you want to look at it. So that's saying, again, my X in that problem is how many tablets does it take to get to the center of a Tootsie Pop? No, I'm just kidding. You don't remember that commercial? The owl and the Tootsie Pop? Anyway, how many pills does it take? Yeah, how many pills does it take? Yeah, 1, 2, and crunch, right? Yeah. How many pills or tablets does it take to get me to the dose I want? What I want to know. So that's my X. And I already know the other number because the order, desired, prescribed, tells me the number I'm trying to get to. And that is 650 milligrams. X tablets. There's the X. The question would be, how many tablets do I need to take to get the right dose, okay? So typically, this is always going to be the side that has your dose, meaning like what's prescribed, what the doctor wanted. And again, this says little colon is saying is to, that's how you would read it. This equal sign, this is like as, basically. Saying that these are equivalent. Somehow these are going to be equivalent. 325 milligrams is to one tablet. I know that because the label says it. As 650 milligrams is to, I don't know how many tablets. There's your unknown. So there's your steps. I found out what I wanted to find out. X tablets, because that's what the question asked me. I found out what I know because I looked at the label. Again, duh, you're going to be given that information because how else would you solve it? And then I know what I want to know, what I'm trying to find out. As this doctor said, I should take 650 milligrams of Tylenol. That's what I want to know. And then that's when I go to the means extremes part. I go, hey, multiply these middles. And again, there's a lot of words here, but this is just trying to. The middle is the means, the outside numbers are the extreme, and it's just multiplication. So again, These are all going to seem really simple, but it's for a reason. So 1 times 650 is 650, right? Pretty simple. 325 times x, 325 just x, because I can't do anything with that until I figure out what x is. So I'm stuck here now. And again, solving for x means I want x by itself. On an equation, the best way to do that is do opposites of whatever's happening. So right now, when I wrote that, I'm saying I multiply 325 by x. Well, let's do the opposite. Let's divide. That gets rid of this 325 because it makes it a 1, and 1x is just x. But whatever I do on one side of the equation, I have to do on the other. I get 650 divided by 325, which gives me, right, 2 tablets, because that's what I wanted to find out. And the long and short of this is, if I want to prove that, I simply replace. Proving means proving my answer correct. I replace the x with what I found out it is, 2 tablets, and I do the middle math again and the outside math again, and this equation should equal each other. And they will, because 1 times 650 is 650, 325 times 2 is 650. And again, I know a lot of you can look at that and do it in your head, and that's fine. You do whatever you want. I don't really care that much, okay? I really don't. If you can do it, do it. But I'm telling you a method so that you have something to fall back on. When we get more complicated, you want a method to fall back on. I think that covers all of it. Yeah. What's my next slide? I don't know. Again, I kind of put this PowerPoint together like last night, so, you know. Also, if you're in A&P, I finished a video lecture. I put the video lecture together last night, so it's on there. That finished editing this morning, so. All right, so let's look at a word problem. People get lost in word problems. I feel like people read a word problem and they get nervous and then they just kind of forget everything. Don't do that. So let's think about this dumb word problem. And this is on the very front, the start of the book, on the very first page there. Page 41 and 42 kind of tee up this problem for you, mainly 41. But this is just another way, this is just an example to say, hey, how I solve it. So their example of incorrect setup is saying, hey, you're making coffee. The label on the coffee, which in this sense is like a medication label, says 2 scoops of coffee per cup, and you need 20 cups of coffee. So if you set that up incorrectly, in this case, they're writing the numbers without estimate or labels. What they mean is if you write the numbers down just willy-nilly and you don't put them in the right place, and you don't have labels, like in this case, what I called labels is units of measurement. And in this case, it's really dumb unit of measurement, but I say dumb like silly, but it still applies, just like medication and tablets. 2 scoops, right, is 2 scoops of coffee. That's your measurement, and to 1 cup, that's the ratio they're saying. So they're basically saying here, 2 scoops to 1 cup is the first ratio that I know because the label of the coffee said this. Does this make sense what I'm saying? Like this is a ratio, right? Equals X scoops to 20 coffees. I don't know what X is. See, on the question's asking you, the label says you have this, there's your no. You need 20 cups. You need 20 cups. So you also know you need 20 cups, but what you don't know is how many scoops it takes to get there. And so there's your X. I figured out my X is I want to know how many scoops it takes to make these 20 cups of coffee I need for this staff meeting or whatever. So my X in this case is the scoops. And you see that they put their X here. It doesn't really matter because they have the same unit of measurement. Scoops here, scoops is first there. Coffee's second on this ratio, coffees are second on this ratio. And so their point with this is it matters in setup that you write out the units of measurement, you put them in the right place, because if you reverse these, you're going to get a completely inaccurate answer. So they tell you, hey, all right, you follow your steps. You multiply the means and extremes again, which is 1 coffee times X and 2 scoops times 20 coffees. So 1 times X ends up just being X by itself, right? Because 1X 1 times anything. 1 divided by itself is 1. 1 times 1 is 1. It's just going to be 1. That means it's not going to change anything. I can drop this 1x. The 1 can just go bye-bye. I don't need it. And that means it's really simple. I'm just doing multiplication because in the extremes is 2 times 20, which equals 40. And so again, my x was the scoops. Where'd it go? So I bring that unit of measurement down. So it's saying that to make the 20 coffees, I need 40 scoops. And again, you can do this math in your head. I know most of you can, but it's just setup. And again, if I took this to prove it and I put 40 scoops where the x was, it'd be 1 times 40 is 40. And 20 times 2 is 40. 40 equals 40. I have proved my answer correct. And I wouldn't say that you always have to do a prove your answer is correct. But I tell people, don't forget that's an option to make sure. Because if you're ever confused and you want to double check your answer, that's a way to double check it. And if it doesn't equal, then you know you did something wrong. And the 2 most common mistakes is setup, incorrect setup, not putting the right unit of measurement in the right place. And the second one is literally, this is going to sound dumb, but it's literally just punching stuff in the calculator wrong. That's all it is. When I divide something in the calculator, if it was saying 4 divided by 2, when I write this in the calculator, I write 4 first, division symbol, then 2. Because that's saying 2, that's asking the calculator to tell me, hey, how many times does 2 go into this 4? That's what it's saying. Okay? So don't forget that. That sounds simple, but if you flip it, you're going to get the opposite answer. Because anybody, what's 4 divided by 2? 2. If I put this in the calculator backwards, though, I would be saying 2 divided by 4. Now that's asking me, hey, how many 4s go into 2? And that answer is a half. So now it's completely flipped, and you'll have the wrong answer. And you bet your bottom dollar, I don't know where that came from. That's from a song. I don't know. I just thought about that phrase. I just said that, and I don't even know where that. You know that we have those phrases, those idioms that just come from nowhere. So I'm like, where did that? Who came up with that? Anyway, whatever your bottom dollar is, bet it. All right. That I will have an answer choice on an exam that is like the correct answer, and then the flipped reverse. And you're just like, that's mean. Sure, if you want to call it that, but no, that tells me that you set stuff up correctly or incorrectly. That's what it tells me. So to summarize the final all of this, checking your answer, you just take that number, substitute it for the x. The x was representing your unknown. You found the x. Yay, you know what the unknown is now. Do the same multiplication, middle, means, and then the extremes, the outsides, and those products of your multiplication should be equal to each other. In this case, it was the scoops, 40 and 40, whatever it is. Question? Uh-huh.
And when I broke everything down, I got 2x equals 20. And then divided, basically got x equals 10.
I don't know how do you get 2x equals 20?
So at the top when you did 325 milligrams, you multiplied it by x, right? So down here I get the 2.
It's about what position you're in, though. Not about, you don't just multiply one. Did you do middle and outsides?
Yeah.
Now, how did you place them? Read off exactly how you placed it for me.
Okay, so I put the 2 scoops.
Okay, 2 scoops. Okay, hold on, my thing's not writing. Hold on, wait, hold on. Come on, wake up. Okay, okay, there we go, 2 scoops.
And then the little dot.
Yep, colon.
1 cup.
Okay, yeah.
Then I did equal x scoop.
Right.
Dot 20 cups. And then I did 2 multiplied by.
Yeah. What did I do then?
That's the outside, right? Then I did, yeah. And I got 28.
No, yeah. So, did you set it up like, does it look like that? So, it'd be insides is 1 times x. outsides is 2 times 20. So 1 times x is just going to be x by itself because 1 times anything is just that number, in this case a letter. 2 times 20 is 40, and then I'm done. That's it. And then if I took 40 and put it right here, you can see, right, if I did a means and extremes again, 1 times 40 is 40, 20 times 2 is 40, 40 equals 40. I'm done. So I think you jumped over, like, again, you're going off what I did before. You can't just these got to be in the same place. So I put scoops first, cups, scoops first, cups. You did that. Yeah, same like placement of the units of measurement, and then it's always going to be middle times each other, outside times each other. And if you mess up placement or you don't multiply middles and the outsides together, if you multiply like a middle with an outside, it'll never come out right. So, okay. Sorry, and I wasn't calling you out to do that. It's a good learning thing for people. But I can't, for me to help there, I need to just see what you did. But you see, that's a little bit why math is a challenge sometimes too, because it does matter. Setup matters so much, and we all have to kind of learn it for ourselves. But yeah, the end goal is that the products should be equal. And I'm preaching this class, this semester, I'm preaching the like, hey, check your answer if you're ever confused, if it doesn't add up, okay, to you. If you look at it and it says, that doesn't sound right. Because I promise you, if you simplify it in your head and you don't overthink it, I promise you, a lot of our math problems we're going to do, you could probably do in your head, honestly. If you sat there and thought about it for a minute, and that's why it's not too hard. But again, my goal for this class is to sprinkle in some nursing-specific stuff to help you hear it already and hear it again in the program and give you just some kind of formula, some kind of foundation to go back on so that when you get more complicated things, you have something to build on. Okay, so let's look at a medication problem real quick, and let's think through it. So this first one, let's work through it together, and then I got a couple more I'll let you kind of do, all right? So I'm going to ask you guys. So here's your, hold on, let me, I'm trying to figure out why that looks that way. People are already answering. Where'd you guys go? You guys are too fast. I know you didn't write that. All right, well, why is this looking like that? Well, okay. So here's your problem. Again, it's a word problem. Patient is prescribed 600 milligrams of ibuprofen for pain relief. Again, these are made up numbers. And guys, don't ever get hung up. Like I've taught someone that used to work in pharmacy or med techs and stuff like that who know a little bit about medication. This class throws all that out the window. I'm not trying to make you understand medications, names, none of that yet. That is all the nursing program. We are just trying to get some basic math caught up with here. So I could put 600 milligrams of, I don't know, whatever, cyanide. It doesn't matter, okay? It is irrelevant. So just throw that out there. If you have a history of working with medications, don't ever overthink it. We're looking at math. We're not thinking that way, okay? So don't worry about that. So 600 milligrams of ibuprofen for pain relief. The available ibuprofen tablets are labeled as 200 milligrams per tablet. I have spelled that out entirely, but the question is, again, what's your X? How many tablets should the nurse administer to provide the prescribed 600 milligram dose? So I've spelled this out as best we can. This is how many tablets should the nurse administer? There's your X. Keyword there was how many or how tablets. So that tells me what? X is some number of tablets, right? Like X tablets is what I'm looking for. So there's your first step. You remember the slide. My first step was find the unknown variable. In this case, the unknown, and you guys have already answered again. Some of you, this is going to be easy, but let's just talk through it. My unknown is X tablets. So there's my unknown. Next step, find out what do you know? Anybody? What's the left-hand side of my equation going to look like? What do I know? Nope, not 600. There you go. 200 milligrams per tablet. Because you see, the key word here is this, the available. So it's all about like sight words. The available is labeled this. There's my no. Let me make that a little easier. Okay, so there is so I've got part of the equation shaping up now. So here's my no. How would I write it? how would I write my no on my left-hand side? 200 milligrams is to what? 1 tablet. Again, this is going to sound really slow and redundant, but I promise you, we spend the time now. Huh? Good, that's good. That's why we got to take the time, because some people learn way faster and learn differently than others. It doesn't matter, but we got to take this time. This is the time to get the questions out. This is the time to get what you think are stupid questions out of the way. I don't want you thinking you know how to do it and then 3 weeks from now be as lost as last year's Easter egg, as my dad would say, okay? 200 milligrams is to 1 tablet. I already know the X is going to be tablets, so I already know I can actually place my X on the other side of this guy. I can place my X here if I wanted to, because I already found out what it is. And you see how I placed this? This was the second in this ratio, so the second in this ratio has to be tablets. Does that make sense? Because same unit of measurement goes in the same place. So this means that this first part of the ratio of the side of what do I want to know, what I want to find out, has to be in milligrams. So we know this one pretty easily. What's the want to find out, I want to know, what's that? What number is that? That's the 600 milligrams. Because here, the key word here, the sight word is prescribed. This would be the same as ordered. Doctor said do this. Prescribed 600 milligrams of ibuprofen. That's the want to know. I want to know how many tablets it takes to get here. So 200 milligrams is to 1 tablet, as 600 milligrams is to X tablets. And like I said, some of you already figured it out, but okay. So let me ask you this. What's the next step? What do I do next? No, not divide. You multiply. Now dividing, you're jumping the gun there, don't you? You technically could do that ahead of time, but we're not going to skip any steps. There's some people that this method is going to make you groan, and I get that. I promise you. When I learned ratio proportion and another one called dimensional analysis, my thought was, this is stupid. Why does it take? I can just divide. I can just multiply. Why do I need to do this? I agree with you. I agree with you, but some people need to learn this way, and some people need a formula to fall back on. So we've got to spend the legwork developing it, and then I can show you your easier formula, and you can off to the races. But I can promise you, if you don't know how to do this one, it limits your ability to solve some of the problems from chapter 1 and 2. It limits your ability to apply this to anything. I can apply ratio to proportion to anything. As long as I have a known ratio, I can find it out. I showed you guys the first day, right? If I know 1 teaspoon is 5 milliliters, you could ask me how many milliliters 16,000 teaspoons is, and I can very easily tell you, okay? So, means is first, right? Multiply. 1 times 600 is what? 600, right? 1 times anything is just going to be that number. And notice as I do this, right? Notice I didn't bring down any units of measurement, right? I didn't write milligrams here, so I messed up there. Hold on, let me fix that just for posterity. 600 milligrams is to X tablets, okay. Notice I didn't write any units of measurement because I set it up correctly first on the leg, on the first step. I don't need to bring any units of measurement with me after this because I know I set it up correctly, and I know when I'm done, my X is going to be what I was trying to find out. So as long as I know I set it up correctly, that's why the book encourages you to put the milligrams, the tablets, whatever it is on the front end, so that you make sure you set it up correctly and you don't just write the numbers. So when you get to the end, you don't have to stress about it anymore. You know you found the right thing. So 1 times 600 is 600. That's the means. Now the extremes is the outside, what's 200 times X? 200X, okay. So now I'm stuck here with this. Again, I didn't bring those unit of measurements down because I don't have to. So 200X equals 600. The goal again is to find out what X is. That was the whole goal of this. So 200 times X is saying 200 is multiplied by X. I can't do that because I don't know what the X is, so I can do something else. I can always do the opposite of whatever multiplication is. In this case, this is the same, this is Skin's theme, this division, right? So 200 divided by 200, just X by itself, right? X equals, but whatever I do on one side of the equation, do on another side. So 600 divided by I need to restart these. I think they're lagging behind a little bit. They're struggling. There it goes. 600 divided by 200. Anybody gives me x equals what? 3. Here's a trick, by the way, too. This goes for any math you're doing, multiply and dividing. If for some reason you were on a desert island, you didn't have a phone or a calculator, and you need to figure some stuff out, here's an easy math trick. When I have these zeros like this lined up, right, you can do what's called, what's the right term? Cancel zeros? I forget what the right term is. Look, watch this. If I take away all the zeros as they, If I take away all the zeros as they line up, I just get rid of them. 6 divided by 2 is still 3. 600 divided by 200 is 3. 60 divided by 20, 3. You see that? So if that was like, that blew your mind and you're like, I hate that, I can't do it, don't worry. It's fine. Just ignore it. Just forget it. Let it go. It didn't happen. But if that's helpful, do that. Does I have a question? What? Oh, yeah. Oh, yeah. I'm thinking of like the Linkin Park song. If you like rock, they have a new lead singer and they have a new song. I can't remember the name. It's Meaningless Machine or something like that. It's really good. I think it's a Meaningless Machine. It's good. What were we doing? What's going on? Oh, X. Yeah, I was just showing you that quick little cool math trick. Anytime you have a bunch of zeros that line up, like again, like if it was like 7 million, right? I know I'm taking a sidebar here, but 7 million divided by 2 million. Actually, let's do it in more pretty numbers. 8 million divided by 2 million. I don't know why I'm turning into the epic summer movie voice, but coming this summer, Channing Tatum plays, I don't know. Is he still relevant? You know who's in everything? What's his name? Jason Momoa or whatever. He's like in everything. He's in the new Minecraft movie, which is just, bah. Anyway. Golly. That man needs to take a break. He just, let someone else. So, whatever. Coming this summer, 8 million divided by 2 million. You see 8 million and 2 million and you go, panic, right? But look, if all my zeros line up, I can just start canceling zeros out as I go, as long as they're even. Because 8 million divided by 2 million is the same as 8 divided by 2, okay, which is 4. Yep. It will be the exact same answer.
Okay, I'm just getting confused like on the word side. Like anything that's like prescribed, ordered, this is one of them, right?
Well, I didn't see the last part of the question, sorry. If any, what was the last part?
Prescribed,
Yeah.
ordered, that's what you want to know.
That's what we want to know, yeah. If it says prescribed, ordered, the doctor asked for, ordered, that's all directing you to think of that next following statement is going to be talking about the amount of medicine that you want to find out about, like that you're trying to figure out. So let's do it. I have a few more, but so anyway, that trick aside, that's a nice trick if you forgot that from math class and whatever. So yeah, our final answer is x equals 3 tablets, and I'm specifically writing tablets. So guess what? If you wrote 3 up here on this, it's probably in red. Although if you just wrote 3, it's in, well, these are all not, okay, I don't know. It's supposed to show me which one's right and wrong, I thought, but whatever. I put in, it might have said, no, it doesn't matter about words, but I specifically wrote the correct answer as 3 tablets. Not just 3 what, right? Like if I said, hey, give that patient 3. 3 what? 3 slabs? What do you mean? What am I giving him? You have to be specific, right? So 3 tablets is the correct unit of measurement, the right thing. So on your question, let's do another one and talk through it again. This is going to be boring for you if you get it. I'm sorry. It just will be. You can, tune me out, take a nap. I don't really care. You do what you want to do. But for those that need it, we got to spend the time. Oh, this thing. I got to restart this thing. It's really struggling. Shoo. Okay. I'll make this one bigger. All right, so another one. A patient, and again, a lot of you can do this in your head. Patient's prescribed 1,000 milligrams of metformin for diabetes management. The available metformin tablets are labeled as 500 milligrams per tablet. Question is, how many tablets should the nurse administer to provide the prescribed 1,000 milligram dose? So I'm gonna let y'all work that one for a minute, but I give you the hint to start with. To start with, what am I trying to find out? Anybody? What am I trying to find out in this question? How many tablets? So my X is that, right? X tablets, I've established that. I want to find out how many tablets I need to give this patient to get to what I want to know. So that part is the doctor's prescription, which is, anybody? 1,000 milligrams of metformin. So basically, what I want to know is how many tablets does it take, given the available, what I do know, to get to that dose for them. And again, most of you can look at this and go, oh, that's, you know how many tablets that is. Yes, most of us can do that. But it's about establishing a rhythm here. All right, has anyone answered? I don't even know. Let's see, where's the list? Some of you ready-ish? All right, what's the answer, anybody? 2 tablets, that's correct. All of you that put 2, you're wrong! Just kidding. I'm only yelling to keep you awake. But you are categorically wrong, okay? Now, I won't get that petty. I can say with pretty good confidence I don't have petty questions on the exam where literally one of the answers is 2 and one of the answers is 2 tablets. I should, but I don't get that petty. But pretty much, if you'll notice, all the answers you'll see on the test are going to have unit measurements following. Because again, it's to what? Specificity and stuff like that is super important in healthcare. The goal of healthcare and dosage calculation should always be limit any room for error, limit any room for misinterpretation, limit any room for mistakes. So yes, it is correct. 2 tablets. And look, only 69% of you got it right, because some of you wrote 2. Haha. I figured out how to hit the right answer now. Okay, so back to the question. Let's go back there. Did that one make sense to you? Did anyone run into any problems? No? Let's talk through it, all right? Again, we're taking a lot of time with this. I got one more question on this PowerPoint at least for that. And I've got really a lot more questions too. I got a bank of them, but on another sheet of paper. So, all right. So we established what our X was, right? Our X was, and again, I'm going to highlight these word problems so you know what you're looking for. Keywords, sight words, right? So I highlighted that first thing we do is find our X. So the question was, how many tablets? So there's our X, the X tablets. I found it. Next thing, find out what we do know, or you can, I mean, it doesn't really have to be in that step, or you can find out what we're trying to find out. I like to go with what's the order next, so I get one side of the equation done. So when I'm saying, what do I want to know, I'm always looking for words like prescribed, ordered, things like that. That's telling me what I'm trying to get to, my goal. I can't give up I as a nurse, no matter what level of nurse you are, except nurse practitioners, I can't just decide what I'm going to give. It has to be equivalent to what the doctor ordered, okay? Now, we'll talk about conversions in the metric system because we can convert to do math, but conversions don't change the amount of medication it is. It just changes the unit of measurement. So ordered is directing my eyes to the want to know. All right, how many tablets should the nurse administer? So what do you know, right? Or what do you want to know? I want to know how much I need to get 1,000 milligrams, right? So my X is tablets. So that's one side of my equation already. The want to know is 1,000 milligrams is to 1 tablet. That's it. That's simple. Okay. That's the want to know equals what I already do know. So look for the keywords again. The available. There's a keyword. The available. I mean, this is like what the label says. This is what's on the pharmacy. This is what's on the pharmacy formulary. This is what's in my Pyxis. The available metformin tablets are labeled 500 milligrams per tablet. Look, it gives us to it right there. Per tablet. That's basically saying, right, 500 milligrams is to 1 tablet per tablet, right? So there's our know, our known, or what we know, 1 tablet. And then we just do the math like we've been doing. Middle, the means, the outside, the extremes, 1 times 1,000. Wait, what did I write? I wrote something. Oh, where'd the X at? Where'd the X be at? Okay. Yeah. Got side railed on the men and women discussion. Yeah, X is there. So yeah, 1 tablet times 1,000 just gives me 1,000. 500 times X. And so let me just make this point too. So 1,000 times 1 equals 1,000. 500 times X is 500X. I don't really know why I put the X over on this side. I have no reason for that. And it doesn't matter, okay? I mean, if I flip this, right, if I put this over here, whoops, this doesn't change the problem. You see what I'm saying? No, it doesn't matter. It doesn't change the problem. I'm still going to do division on this side, on that side, and I'm still going to get X equals my answer. So let me make that point. Sorry, I forgot to. But yeah, I just, for some reason in my brain, this just looks correct. I don't know why. I have no other reason than it just makes sense to me. So if that messes with you, then keep the X on the right-hand side if you want. But again, it doesn't change stuff because I know I'm going to get to the right answer because I set it up correctly in the start. I put milligrams first, tablets. Milligrams first, tablets. And so that's the theme. It's whatever we're talking about. Milligrams, micrograms, grams, tablets, milliliters, pumpkins. It doesn't matter. Scoops of coffee, right? As long as it's the same measurement. So 500 is dividing it by, because that's the opposite of multiplication. That gives me X by itself, because 500 divided by 500 is 1, and 1X is just X. That means I do this on this side. 1,000 divided by 500, and again, if I was punching that into a calculator, that's 500 division sign, or excuse me, just told you wrong. It's 1,000 division sign 500, because that's telling your calculator to see how many times 500 gets into or goes into 1,000. So anyway, your final answer is X equals 2 tablets. Bring that unit of measurement down, because that's what you were trying to find out. And so this is saying that yes, doctor, to give them 1,000 milligrams, I pull out the package that's 500 per tablet, and I just give them 2. Again, all that seems like so much to get to a simple answer, but it helps whenever you talk about more complicated things. While y'all do this one real quick, and then we'll take a break, just to practice the medication ones. So this one, very similar to what we've done. It's laid out the same. A patient is prescribed, there's keyword, 125 milligrams of levothyroxine. Again, the medication, it could say anything there. It doesn't matter to you right now. For hyperthyroidism, the available levothyroxine tablets are labeled as 250 milligrams per tablet. My question for you is, how many tablets should the nurse administer to provide the correct prescribed amount, the prescribed dose? That's what you would call it, a dose. What the patient's supposed to get is a dose. Each time they take a medicine, that's what you get. So if you take 1 pill of something, right, that's your dose. So that's what's prescribed to you. If you take half a pill, that's not what your dose is. That's not what's prescribed. So, all right, what was the answer, anybody? Obviously, some people are going to the bathroom. We'll take a break. How much was it? That's half a tablet. Woo! Gotcha. So my guess there would be, again, setup was patients prescribed 125. So there's my, and I want to know how many tablets that is. That's right, 125 milligrams to X tabs. Real quick, the no would be I have 250 milligrams per 1 tab. So what this is saying, look, that's right. That's our correct setup. 1 times 125 is 125. 250 times X is 250. X equals 125. Look at this. Divide by 250 to get rid of it, because that means 125 divided by 250. So now we're telling our calculator, hey, see how many times 250 goes into 125, and it doesn't go in evenly. It goes in only half, 0.5, yeah. So X equals 0.5. So 0.5 tablets, or you could say 1/2 tablets, kind of whatever you would write. Usually I'll do 0.5 tablets because that's what most people's answer would be if they use a calculator. But okay, it's at the top there. So TID, I kind of make a mental note of like, I don't know if that's really useful. It could be, but maybe it's not. The bottle holds 100 milliliters. How many doses will the patient get out of the bottle? Now this is a challenging one, but You can figure it out using ratio proportion. So think about this for a second. Looking at this, what do you know? And this is something that you would know from memorizing some of these conversions. What do you know?
1 teaspoon equals 5 milliliters.
Correct. 1 teaspoon is equal to 5 milliliters. And you could figure that out if you didn't have it memorized by referencing that document. So we know this. The patients that take 1 teaspoon of medication, TID. So 1 teaspoon of medication, 1 teaspoon, TSP, is to 5 milliliters. I do know that. I'm going to put it on the left-hand side. What it's asking you is how many doses. Always cue in on that. I should have started there. I'm sorry. You always start with what's the X. So the X here is looking for that phrase. Your key word for that is always how many something or how this, many this. So it's asking how many doses, which is interesting, right?
So the doses is going to be X.
The doses is going to be X, yes. So look at this. Stay with me. I know it's going to be like, what? There's a couple ways you can figure it out. There's a lot of ways to use ratio and proportion, but we do know 1 teaspoon is 5 milliliters. We know that, okay? I want to figure out how many doses they can get out of a bottle. So this is a different question entirely than figuring out what the dose is, okay? I know what the dose is. It's 1 teaspoon. But here's the problem with it. Where's where you have to think a little bit, right? Teaspoon is the same as 5 milliliters, but if I'm talking about the other information I have, I don't know how many doses is in what. What would be this part, this I don't know that I'm trying to figure out? You're correct, the 100. So again, this is a tougher question, but this is where we're going. But you can see that the way I set it up doesn't change. It's just trying to figure out what's the right information I'm putting in places. So stay with me. 100 milliliters is to X doses. So realistically, what goes on the no side is got to be lined up with this. So we're looking for however many milliliters one dose is, basically. So look at this. So 1 teaspoon is what they take, which we know because we have that memorization down. And I'm not saying you do yet, but you will. We know that 1 teaspoon is the same as 5 milliliters. So how I would write this is 5 milliliters is to, what do you think goes here then?
3.
Nope. Per dose. Because what are we trying to find out? How many doses are in this bottle? So you see, we're not doing, this is an untraditional problem where so far all we've done, right, is figure out like a dose to give someone. That's what we've been figuring out, what the dose is. The dose is this many tablets, this many whatever. This one flips it on its head and says, oh, I'll tell you what the dose is, but what I want to find out is how many doses they're going to get out of that bottle. Now, this is somewhat a realistic question in the general thing. Now, it's rare, but it's realistic in the sense of, especially in home health, when I did home health, when you talk to pharmacies and stuff, you have to know how long a patient's on a medication. If they're on a medication for 6 weeks, well, how many doses is that going to be? What does the pharmacy need to send them to go home with? You know, that kind of stuff. Or like they have to change their wound 3 times a week, and they're going to do it themselves at home. Well, how many dressings do you send home? You see what I'm saying? If they need 1 dressing 3 times a week, how many dressings do they need for 2 months? You see what I'm saying there? So, like, it is somewhat a relative question, but my point to these kind of questions is to challenge you a bit and say, hey, you can still use ratio proportion. So the reason I started with the 5 milliliters to the 1 teaspoon is because we have to know that to be able to figure this question out. And that's why I said some of those conversions are going to start just becoming memorization. I know that, so I can plug it in. Does, right, in mLs, doses. And again, it kind of goes back to, I figured that out because my key to that, I'm going to get to your question. The key to that was I was looking for the how many. I'm looking for the X, the unknown variable. And the unknown of what it's asking is how many doses, not how many tablets or how many milliliters, how many doses. What was your question?
Why wouldn't you put the 3 right there?
What? Where are you getting the 3 from? TID? Because it doesn't ask us how many days it'll last. It asks us, it says, hey, a bottle has this much. 1 bottle has this much. I know you're going to give this much every time they take it. I just want to know how many it can get out of 1 bottle. Not how long the bottles. If I was asking how many days the bottle would last, then the 3 would matter. You see what I'm saying? Because I'm taking it 3 times a day, that's going to add up. And so when someone said the 15, you're on the right track of thinking, right? Yeah, like they get a dose, and that means they're probably going to end up taking 15 milliliters a day. So if this question asks you, give you the same information and ask you, hey, how long is this bottle of 100 milliliters going to last? How many days? That would be something like, oh, well, you know, I go through 15 milliliters for every 1 day. I start off with 100 milliliters. I just want to know how many X days that's going to last. That would be a different question, but I can still figure it out the same way. And that's, again, why I do like ratio proportion, and I'm still teaching it because I think that it's practical. You can use it. Once you learn it really well, you could use it to solve pretty much anything. And that's what all those word problems are doing at the back of chapter 2, is what they're doing is trying to get you to use it to solve kind of everyday weird problems. So this, go back to 23, our question is that 5 milliliters is to 1 dose, 100 milliliters is to X doses, and now I just do what we've been doing. I do the means and extremes next because I got it set up correctly. I'm running out of room. So that's 1 dose times 100 milliliters. I'm just going to write it down here. That's just 100 milliliters. I'm not going to pull the milliliters down. I don't need to write the unit of measurement on this stage, at this step, because I set it up correctly. Yes?
So 3 times a day is considered 1 dose?
No. The 3 times a day is irrelevant to the question. The question asks you how many doses will the patient get out of this bottle. 3 times a day does not matter to that.
But if it asks for the days,
If it asks for how long the bottle would last, how many days it's going to last, then it would matter.
I get that, but you know how 1 teaspoon is 5 milliliters.
Right. 3 times a day means I take that 1 dose 3 separate times a day. So I take 5 milliliters in the morning, 5 at lunch, 5 milliliters in the evening.
So that's what I'm saying. So it doesn't matter how many times they take it. That's all considered as 1 dose.
No. Those are 3 doses a day. 3 times a day says I take 3 doses in that day. If I told you to take 1 tablet twice a day, how many tablets would you take in a day? 2. How many tablets would you take at 1 time, though? 1. That's your dose, 1 tablet. A dose is just what you take at 1 time. That's all a dose is. Do you see what I'm saying? Like if someone said, "Hey, here's a pain pill," right? It's 5 milligrams. Take this pain pill twice a day. In a day, you would take a total of 10 milligrams, but each dose is what's prescribed, 5 milligrams. So we always know what's prescribed because they have to tell us that. What we're trying to figure out is what is that dose equivalent to in the number of tablets and how many milliliters? What does the patient physically have to put in their hand and swallow, or put in a cup and drink, or inject? That's what we're figuring out. Does that make sense? Or is it okay? All right. Does that make sense? That was a good question she asked. Okay, so doses are just looking at what does that person take at 1 time. So in this question, the TID is a kind of a rabbit trail. It's a throw you off. It's irrelevant to what the question's asking you, and a lot of times it will be, unless it asks you something about how long will this bottle last, how many days will this last, how long will they be able to take this medicine. Then it matters how many times they're taking it a day, because if I just said they take 1 teaspoon of medicine daily, that's a lot different amount in a day compared to 3 times a day. But the dose didn't change when I asked that. The dose, if I said the dose is 1 teaspoon, the only thing that changes how many times they take a day is going to be the total they get in a day. The dose is exactly the same. It's still 1 teaspoon. Because 1 times 3 is 15, or 15 milliliters. They would get 15 milliliters or 3 teaspoons in a day, yeah. So a dose is always just an individual, at 1 time I take this. So again, like a bottle of Tylenol will say normal adult dosing is 650 milligrams every 4 hours. That means at 1 time, for 1 dose, you're supposed to take 650 milligrams. But in 4 or 6 hours, you can take another 650 milligrams. And then the medications will always say stuff like, oh, there's a max amount of milligrams a day. And then you could figure out how many doses you could take in a day by doing that math. But that would be the max amount of medicine you could have in a day. But you'd have to still do it in those divided doses. When a bottle says the max dose a day is 2,000 milligrams, that does not mean you can take 2,000 milligrams at 1 time. That's not what it's saying. 1 time is a dose. It's saying that you can, over some divided doses throughout the day, you can, in 24 hours, take this much medicine. Does that make sense, or am I making you guys more confused? I don't know. I don't know. Probably. Yeah, 5 times 20 should be 100. Yeah. Well, 5 times x, or 100 divided by 5 should be 20. So I get 5x. 5 times x can't do anything, so I divide to get rid of the 5. Remember, 5 divided by 5 is 1. I'm left with just x equals whatever 100 divided by 5 is, which, yes, should be 20. So x equals, for that number 23 up there, x equals 20 doses. 20 doses. And you can see it, right? If I take 20 and plug it in here and do my means and extremes again, it'd be 1 times 100 is 100, and then 20 times 5, which is 100. 100 equals 100. I did it correctly. So all we're saying is that every question is going to give you all the information you need. Sometimes it's hard to find where it fits, and that's what we're practicing here. Number 23 is about as hard as we would get right now, and I don't really have, there's probably one question similar to this, so I would pay attention to what we just did. So let me just stop for a second. 22, right? 22, patients discharged with capsule that he is to take BID. How many capsules will he need for 30 days? See, there's where the BID would matter, right? So now this matters, twice a day. So that's 2 times daily. They get 2 doses a day, 2 divided doses a day. How many capsules will they need for 30 days? So if they take a capsule, which is like 1 capsule, and see, ratio proportion-wise, this would be like saying like this. Again, what's my x here on 22? How many, look for how many capsules. There's your x. So my x is basically saying that I want to find out how many capsules they need for this many days. So it would be literally x, I'm just going to write it this way because it doesn't really matter where you place it as long as you do it the same on the other side. X capsules for 30 days. I know they told me they take 1 capsule BID twice a day, right? Which I can do a little bit of quick math and go, how many capsules is that a day then? 2. So I know from what they've told me here, what the order was, that they are taking 2 caps. I'm just going to put caps because that's slang, you know. You could say tabs too, you know. I'm sure that's what they call them on the streets, okay? Whatever. Oh, Lord, help me. I need help. 2 caps per 1 day. You see this? Okay? Per 1 day. There's what I know. So I can use ratio proportion to solve anything. And then I would just do it like I normally would. 1 times x is x by itself, and then I'm just doing 2 times 30. So x equals 60. So I know they need 60 caps for 1 day. And again, I know you could sit there and just do the multiplication and get there. But all these questions are just about learning how to find information and put it in the right place. So we can look at, does that make sense to everybody? Yeah. All right. Last one I'm going to do. I want you to do some on your own. Last one is 21. 21, I guess. Or maybe one more. I don't know. What was 21? Oh, yeah, okay. Yeah, so that is a little bit of a taste of what you would call converting. Now, it doesn't really feel like natural converting. We're going to learn to do this with Unit 2. Converting is basically just saying, well, I have this one way of measuring something, right? There's also another way. Because, right, I can say there's 60 minutes an hour, you know, or I can say there's, I forget how many seconds it is, whatever 60 times 1,200. No, that's not right. 60 times 60 is, yeah, 1,200, wasn't it? I don't know. I think it's 1,200. I could say, right, 60 minutes in an hour. I could also say 1,200 seconds. No one would say it that way. But you see what I'm saying, right? That's the same. They mean the same thing. Right. So if I can say 1 year, but I could also say 12 months. That's the same amount of time, right? I could say 1 day. I could also say 24 hours. Same amount of time has passed. So that's technically converting. And we're going to learn to do that in the metric system where we take stuff like milligrams and grams, who are both measuring medications and measuring weight, and we're going to convert them. We're going to change the grams to milligrams or milligrams to grams. When we start talking about that, they are same. They're still units of measurement. One's just smaller, one's bigger, and we're going to start learning that. It's the same concept. Yes, so your answer is correct. So you earn 5 vacation days every 6 months. How many days will you have earned after 3 years? So this one is saying, again, look for your X. My X is what? How many days? Okay, so X days will you have earned after 3 years? So there's the conversion. I have 3 years discussed here. 3 years. What I know, I can see. They told me 5 vacation days every 6 months. That's what I know. The problem is 6 months and years are different time measurements. So I got to figure out where's in between. Now you could do it either way. When I'm converting stuff, I could say it either way, but there's always an easier way to do it, right? I could take that 3 years, and what I would recommend, right? I'll take the 3 years and just turn that into months. Then I have months and months, days and days, right? And I can work that out. You could theoretically change 6 months to 0.5 years and do it that way, and you would get the exact same answer because you didn't change how much 6 months is worth. 6 months is half a year, correct? Right? So you didn't change nothing. You converted. It's different. Conversion's not changing anything. I didn't change the value of the number. I just changed it to a different unit of measurement that is the same amount, same value. It's the same thing as saying 50% of something is still 1/2 of something. Those are the same thing. I just converted them to different ways of measuring them. That's all we're doing. So I would probably change the 3 years to months mentally. That would make it easier on me, but you could go either way, and that's what we'll talk about with conversion. So these are some of the book's first ways of introducing this to you. And this is like, again, you could call it an extra step, yeah, but it doesn't change how you set stuff up. It doesn't change your process of finding things, right? So the X days, 3 years, I'm going to change 3 years to 6 months. The easy way to do that is just go, well, there's 12 months in a year, right? Okay. 12 times 3 is 36, right? Yeah, 36. I had to think about that for a minute. But look, here's the wild thing about ratio proportion, just a sidebar. If I was stuck and I couldn't just do that math in my head real quick, what could I do? I literally could, this is kind of dumb and redundant, but you literally could, if you were stuck, go, well, I know 1 year, just bear with me here, 1 year is 12 months. I know, yeah, this is a little bit much, but I'm just doing mo as months. But look at that. That's a ratio proportion problem. If I do the same thing, you can see what happens. 1 times x is x. 12 times 3, 36. X equals 36. That's 36 months. You see that? So ratio proportion is nice because you could theoretically use it for anything as long as you have some kind of something you know. But back to the problem at hand. So we change this. We convert this 3 years to 36 months just to make it easier on us. And now we have it. We have 36 months. Mos is to X days. I know I get 5 vacation days, so that's 5, I'll say 5 vacays. I don't know, I'm just making up stuff. 5 vacays to 6 months. And then a little equal sign there. Now I've got my math. So then I end up doing 6 times 36, which is a bigger number, but that's okay. We have calculators. 5 times x. So 6 times 36 is 180. Okay, I was like, I'll try to do it in my head. 180, I'll just write it down here for space. 180. Don't need unit measurements because I made sure I set it up right. I put, wait, hold on. Oh, I did it backwards. See? There you go. I did it incorrectly. Look at this. This is supposed to be vacate. These are days. See what I did? What did I do wrong? I put days first and then months. And then on the second ratio, I put what first? Months, then days. So there's your mistake, right? Now, I caught that early, but, right, if you got to the end and you're like, this feels wrong, if I took my answer and we plugged it into X, I would see immediately that they don't equal each other, and I know I did something wrong. So that's where I'd start to look to see what you did wrong. I did that on purpose. I just want to make sure you guys are paying attention. No, but that works out. That's a good little. So right, I put that wrong. So let's switch it.
No, you had me thinking I did it wrong.
I said, well, that's yeah. So this is gonna be. I put days first over here, so I gotta put X days first here, and I gotta put the 36 months over here. Now we're correct, and we can work it out. So it's 5 times X is 5X, and 6 times X in the middle, that's your means, gives me 6X. And then I have 5 times 36, which is something, I don't know. 65, 80, 90, 1. Is it 180? Oh, okay. It's like 1. So then I just take this, right? Do my normal what I've been doing. Divide this side to get rid of the 6 and get X all by itself. And then divide this side by 6, because whatever I do on one side of the equation, I have to do on the other. And 180 divided by 6 equals, 30, right? I almost said 3, but it's technically 30. So X equals 30 days, correct. Vacation days, vacay days. So basically, what you're saying is, I was curious, I can take this, plug it into the days, plug 30 in, and then do the math again. And it should equal out 180 equals 180. How's that? It's something, I don't know. How's your brain? Is it all right? We got.
Most of the ones on the homework I could just go through and kind of do in my head.
Yeah.
But I see why it's important to know the possibilities.
Yeah, and I mean that's why I've said that some of you are going to be bored at the first part here, and I understand that because I'm a person that can do a lot of it in my head too. And if you like doing stuff in your head, the desired over have method of doing the medication calculation much easier, but there's a big but to that. Again, a caveat. Again, you're ultimately going to make your own decisions about how you figure stuff out. The problem I see for people all the time, though, is that you have to have something to fall back on, some kind of formula. So I will teach everybody the desired over have when we get more into medication. I'm not doing it yet because I really want to challenge you to try and learn this way of doing it, okay? But you don't have to. You will find your own path in this world, young grasshoppers, okay? So you do what you want, but just trying to give you something, again, like you mentioned, something to fall back on so that I always know I can get the right answer and I have something to check it. So I'm wrapping up, but why don't we pick one of these ones from the end here that's random. Okay, here's a good one. This number 3 here is actually a pretty good one because it's kind of, well, maybe not. It's a little weird. But these are in the book. I have these as PDFs just for me for class time. But this is just the couple little quizzes and final they give you in the end of chapter 2 in the book. And of course the book gives you the answers too. So if you're like, I need more practice with these weird word problems, these are the weirdest word problems you're going to get. So the good news is you can try them, practice them, try to prove your answer. If you get them wrong, then you can go to the book and they have it worked out and they'll show you how they got the answer. Now, I think for the final one, they just have the answers, but the previous page on page, the final that this is copied from is page 49 and 50. But before that, there's a multiple choice practice right before that on page 48, and they should have the way they worked it out as well, like how they set it up before that. Yeah, they do. On page 55, 56, they've got answers. So you can always reference a book for extra practice, and that's why they're there. But so let's just look at like number 3 there. The hospital laundry. Ooh, laundry. That's never fun. I had to dig through some laundry looking for a telemetry monitor before. I was pretty ticked that day. The joys of being a charge nurse, anyway. My methodology for that was I wasn't putting my hands in there. I just pulled the laundry bags out and just stepped on all of them until I felt something hard. I eventually found it. It's buried in the bottom. And the closet, the dirty linen closet, was full that day. A lot of poopy people. It was full. It was gross. We found it, though. Got rolled up in the bed. All right, so hospital laundry provides 4 sheets per bed per day. Oh, that's a lot of words. Whoa. How many sheets are needed per day for a 200-bed hospital? Whoa. It's a little weird to wrap your head around that one, right? But that's why I say, hey, start somewhere. So let's just start with that weird one with how many sheets, right? Because that's our X. How many sheets are needed, blah, blah, blah. So I already know, as soon as I see the how many, I know that this is going to be the X. So I'm looking at X sheets. That's what I'm trying to find out. Are needed per day for a 200-bed hospital. Let's backtrack a bit. So it says the hospital laundry provides 4 sheets per bed per day. Here's the key sometimes. It's easier to start with what you're trying to find out sometimes. It's asking us how many sheets are needed per day for a 200-bed hospital. Look at this. The only difference between these two statements is 200-bed hospital per bed. This is saying 1 bed. This is saying 200 bed. Look at this. This says how many are needed per day per day. These are the same. So these aren't going to change anything for me. These are my only difference. That's how I indicated which one I needed to put. So that's a little bit wordy, and I don't really do problems like that, but I'm just giving you an example of like how they can get weird and how you can start finding the differences. So now I've eliminated stuff that's useless to me, and I know I'm looking for sheets, and I want to know how many sheets I need for a 200-bed hospital. So now it's much easier, right? X sheets for 200 beds. And then it just says I do 4 per bed. So 4 sheets to 1 bed. Yep. Does that make sense how we got there? Okay. And so then again, we just do means and extremes. We do the middle. 1 times X is 1X. I'm going to write it kind of in this space here. I'll write it down here somewhere. Is 1 times X is X sheets, and then I'm just doing multiplication. 4 on the outside. 4 times 200. Yeah. 800. So this hospital needs 800 sheets per bed, and you could add per day if you want to add. I mean, you don't need to write all that. It would just be 200 sheets would be the answer, really. That'd be correct, but that's what they asked you. So that's a random one where it throws in the per day thing. But if you look, if the question is giving me a known of per day and it's asking me something per day, those are equivalent, right? It's per 1 day. It doesn't change anything. So that's a really weird one, and a lot of these are weird. And I think a lot of these are these last couple, the multiple choice worksheet they give for you on page 48 in the book, 2F, and this final that's on page 49, is pretty good practice. If you get through the worksheet and you're still like, I just want to repetition this more before the test next week, I'd recommend running through those guys because the book gives you the answers. You can double check them. And they're weird and hard to figure out. But they're worth trying to get through because I think they're good practice. So how do we feel? Okay? Pretty good? It's really not too bad, right? I mean, most of the math you can do in your head. I mean, again, your 2 biggest uh-ohs or whoopsies or whatever is incorrect setup, right? Like I did earlier, right? You put the wrong unit measurement first, and then when you do the other ratio, you flip them. That's going to mess you up. And then most other people's is simply just doing the division wrong when they pipe it in their calculator, or because like top number is divided by the bottom number. That is saying that the bottom number, we're trying to see how many times the bottom number will go into the top. So like 4 divided by 2 is asking your calculator and saying to you, hey, calculator, tell me how many times 2 will go into 4. That's what it's saying. So you got to make sure and type top number, division symbol, bottom number. And if you flip it, it's going to always flip your problem. It's always going to do that same thing to people. I always know when you do that, right? Because the answer might be 2 and people say 0.5. The answer is 0.5 and people say 2. Those are the 2 big hang-ups for most people that mess them up. Okay?
So there was no need to create a fraction.
What's that?
There was no need to do the,
No, there's no need to do division here because my only time that happens is right when I have different. But if I have 1 times x, it just leaves x all by itself. That means I don't have to do any division to get x by itself now. It's just there. Yeah. Right, because you would be basically saying like, let me go back to that. 1x equals 4 times 200 is 800, right? So if I wrote, that's what it looked like. Are you with me? You with me? Okay, because I know you said, whoa, that was, yeah, so some people just ask that, well, look what I did if I did this, right? Divide by 1, it doesn't change anything. Divide by 1, it's still 800. So I still end up with x equals 800. So as soon as I have 1 times x, I'm like, yay, I'm excited because I know that's one less step I'm going to need. Anytime there's in the means or the extremes, it's 1 times x, I know I can just have x, and I know that I'm probably going to have a simple problem where all I really need to do is multiply. But if I have any number, if this was like 4 sheets per 2 beds, that would change it, right? Because then it'd be 2x equals 800. Then I'd have to do division, 800 divided. You see what I'm saying? It would come out differently. Does that make sense? But yeah, if I see 1 times x, I'm pretty happy because I know that it's probably going to end up being just a multiplication problem, and it's going to be real simple. And again, you could figure it out in your head, but this is just methodology to get you there.